Okay, my friends, today's kind of exciting. Today, we're going to start doing our first probabilistic experiments in Math 105. Up till now, we've been measuring things and checking things and kind of verifying things, and that's been great. I mean, all of that's been great. We've been learning tons of good stuff, everyday life math. But today, we kind of begin the look to the future. Some of you are going to take Math 243 and Math 244, which is completely rad. If you don't, though, it's totally fine. If you don't, it's still important to be able to look at scientific results, whether they're psychological, whether they're medical, whether they're engineering, whatever. Looking at results of experiments and checking them for validity, checking them to see how they did the experiment, and more importantly, how they measured what they were looking at. Okay? So even if you don't go beyond Math 105, this is the kind of stuff that happens all the time. It's happening right now. Right now, as I record this video, I don't know when you're watching this, but COVID is still out there, and there's all this research being done into the best ways of treating COVID. And people are saying things like, I heard that X treats COVID, or somebody told me Y treats COVID. And whenever I hear that, I say, where did you read that? Send me the source, send me the experiment, so I can check a couple things. I want to see who they measured. I want to see how many they measured. I want to see where they measured. I want to see if there's any differences in the data. All of those questions will be addressed in later math courses if you take them. But there are some basics we can look at today, which is how they get results in any study. So we're going to do our own study. I brought a coin with me today, heads, tails. It's completely out of focus. All I see is my shiny nose. Heads and tails, penny. Our first experiment number 1 is going to be simple. We're going to flip this coin until one of those sides repeats. So we're going to flip it, then flip it again, and if necessary, flip it again until we get a side to show up twice. Not necessarily next to each other in sequence, but just twice. I'll demonstrate what I mean. All right, so I got heads. I just dropped it. I'm not going to count that as a flip because it didn't really flip through the air. What I just did there was defined my variable. A flip of a coin has to flip. It actually has to get spinning in the air. So I flipped heads first, and I just flipped heads again. I got to repeat after 2 flips. I'm going to put that 2 up on the board here. 2. Okay, that is the result of my first trial. So I ran a trial of my experiment. The variable I'm measuring is how many flips it takes until I get a repeat. And the result of my first trial is 2. Now, I'm going to do another trial. I'm going to use the same coin. In real experimentation, you would probably have a different subject that you would use, but all coins effectively are equal for what we're doing here. So I'm going to use the same coin. When we do this in class, everybody has a penny and we're collecting all the data together. Okay, that one did flip and then fell. I'm going to count that. That's heads. And I got tails. So no matter what happens on the next flip, it's going to match either heads or tails. And I got heads again. Heads, tails, heads. That one took 3 flips. That one took 3 flips. Let's do one more trial, then stop, and then chat. That's heads. That's heads. Boom. That one took 2. That one took 2. Okay, let's pause for a second. I've run 3 trials of my experiment now. We're going to run more, many more, trust me on this. A very common measure that is used in statistical experiments is called the average. And I'm sure all of you have heard of the phrase average before. And I bet you that roughly the same number have calculated an average before. So the simplest kind of average is called the arithmetic mean, or the arithmetic average, or probably what you think of when you think of average. There are other ways of averaging besides the typical way. You actually did one back in exponential modeling. It's called the geometric average, but don't worry about that. The arithmetic mean, or the normal average that you're used to hearing about, is found by adding up all the values of the data and then dividing by how many data values there are. So in this case, if we were interested in I'll put this down here, the average number of flips until we got a repeat. let's define that to be our statistic. We are interested in the average number of flips until we get a repeat. We'd have to add up our data. I'm going to get a little color coding here if that's okay. We'd have to go 2 plus 3 plus 2. And then we'd have to divide that by how many data points there are or how many trials I did. So 1, 2, 3, we would divide that by 3. So the average number of flips in this case right here would be 5 plus 2 is 7 over 3. I'm losing my color coding. 7 over 3, which is going to be about 2.3. So if you wanted to stop your experiment right here and say, I think I know the average number of flips is 2.3 until you get a repeat. But I doubt very many statisticians would ever stop an experiment after 3 trials. Because that's not enough. You haven't seen enough of a representation of the population you're studying. The population in this case being all possible coin flips. But, I mean, think of any population you'd be interested in studying. 3 probably doesn't give you a very good look at the average. So, let's do it again. Heads. Heads. I got another 2. So my next trial would be 2. Let's update our average with this new information. Well, it's about 2.3 again, but it's 2.25 to be more precise. 2.25. So you might say something like along the lines of, well, the average went down because it was 2.33333, and now it's 2.25. Remember, I'm leaving something off of this, the margin of error. Any of these things have a margin of error. We talked about that before. I don't want to get too crazily into that here. I'm going to mention it here, probably mention it again in the future, but the idea is that a margin of error has to be applied to any of these statistics. And I don't want to get crazy into measuring margins of error for this experiment. Let's do another try. We need more data. A sample size of 4 is not enough. All right, I got a heads. I got tails, so I know I'm going to match whatever. Heads. Heads, tails, heads. That's 3. That's 3. Here. And the unit on that 2.4, it has a unit, right? If you think about this, this is 12 flips over 5 trials, so that's flips per trial on average. Flips per trial on average. You can see what's going on. The average is changing with each additional data point. So theoretically, what we'd have to do is keep doing this experiment until we got an idea of what was actually going on. This is not the most efficient way of doing this. I mean, a coin is a beautiful randomizer. It really is. But there's a better way. Let's take a look at it.